explain you both. So according to Kirchhoff rules, there are two rules. One is the current rule and the other one is what? Voltage rule. Isn't that? So let me explain you firstly the current rule. According to current rule, what does it suggest? The algebraic sum of what?
That a junction is 0.
Yeah, current in the junction is 0.
Junction means any point you can take, no? Like
Yeah, any joints.
Okay.
This is like I1 and I2 and I3 leaving one and I4. Right. I mark it like this. Now have a good look at. I'll mark the same thing with some numericals. 10 milliampere. 10 milliampere. Then what 15 milliampere. And here there are what 30 milliampere. What about this one? I4. How can you find out I4?
What 25 is coming in and 30 is going out.
Yeah. What does it suggest then? What does it suggest? So I can add it like 15.
So is it 40
10,
minus 15?
That is negative.
50, and minus what? 30 minus I.
So give me 1 second.
Yeah. I4 equals to 0. This is how you write. Algebraic sum should be the 0. So I4 should be what? This one. 25 minus 30. That means your answer becomes minus 5 milliamp. What does it suggest? Minus. Minus means my initial direction was wrong. It is not going away. Actually, the current is what? And coming one towards the junction. Can you understand that? If you get a negative answer, that means your initial predetermined.
That means direction is flipped, right?
Yeah, flipped. That means your predetermined direction is a wrong one.
Yeah.
Okay.
So you can take a direction and find the actual direction. No?
Yeah. Just leave it with negative answer.
Okay.
Right?
You don't have to change this.
No, you don't want to. The negative sign already included. No? Electrical and voltage rule. Well, how about the voltage? The voltage rule means that the total potential drops around a loop is equals to a total EMF supply. Have a good look at in this one. This is what the EMF supply, what is it? It's like 3 volt. And these two are in what parallel connection, all joins to this junction, this one and this one all together. So how about it? The potential drop around the first part is like 0.85 volt. So the entire rest should be dropped around what? This variable resistor. So see, now it's conserved. Don't you see that? So the current rule and the potential rule, voltage rule. Let me explain you the voltage rule. In the voltage rule, it makes like this much of sense. This is what the only supply EMF, and there is a what R1 resistor, and there's another one R2 resistor. So what would be my current direction? This one is the current. I is a consistent one because why? It's the only path. Only path means all the electrons has to travel across all these points. That means the current is constant. So
the path means because it's one cell, no?
Yeah, one cell. So the voltage voltage drop is this one. The second voltage drop is this one, V2. So I told you, you have to start up with a loop. I am going to start the loop from this direction and along clockwise direction. There's another junction like B, C, and D. What is my loop? If I consider the loop is
A,
like
B, C, D, D, C.
A, B, C, D and again ending at
A.
E, because
A.
you started from
And
here and you ended at the same point by considering a loop. According to EMF, definition of the EMF is also what? The amount of energy required to bring what? A unit charge around a loop of circuit. Loop should be completed at when it comes to the starting point. So how about it? Epsilon means the, what is it called? EMF. EMF should be equal to all the potential drops around the circuit. First potential drop is V1, second potential drop is V2, and now I can apply what? Ohm's law. Applying what? Ohm's law. V equals to IR. So I can leave it like E epsilon, and this one is the same current and R1. The other one is same current with R2. So I can simplify it like I R1 plus R2. Can you just understand?
So electromotive force
Matish, I
about
sent no.
sure.
Electromotive.
So basically electromotive force across the entire loop is
It's a sum
V1
of all the voltage drops.
Yeah, sum of all the voltage
sum.
drops.
Okay,
That's
fine.
what the Kirchhoff's second rule. So
Because
this can get even complicated if I include like few more things like this. Have a good look at. Now I'm going to complete these two in opposite directions. I, the same current, I. But here there is a one problem. What is it?
two cells in different orient.
If I started to mark the points like A, B, C, and D, and again finishing at A, considering the clockwise direction as the positive, if I get a negative answer, what does it suggest? That means my predetermined direction is a wrong one. Because if the E2 cell is what? More powerful?
Then the net movement is anti-clockwise.
Yeah, anti-clockwise. Who knows? So I just pre-assumed like this one is the powerful one. It might go wrong. If you get a negative answer, that means your initial predetermined directions are wrong. That's it. Just leave
But you
it.
can still use it, no?
Huh?
You can still use a negative value, no? Like it's a vector.
Yeah,
So
yeah. Just write the negative value. That's it. The
So, but
meaning of the,
basically whichever one has the higher voltage, it will go in that direction.
yeah, higher EMF. This one has an internal resistance of simple R1. This one also has an internal resistance of simple R2. So how about the EMF? Total EMF should be equal to total potential drops. First EMF one is E1 by considering this one as by considering. So let me write by considering.
positive, no?
Considering E1,
Positive.
considering what? E1 is greater than of E2. I'll use E1 and E2 because always pronouncing epsilon is a really annoying thing. What is it going to be now? E1
E minus E2.
E2 equals, what is the other part?
Sum of all
Now have a good look at
world.
how does it change. Now have a good look at the first drop from A to B is what? This voltage drop of V1. There is a voltage drop of V2. There's another voltage drop of what? V3. And there is another V4. Understand?
V3 and V4 are there because of the internal resistance, right?
Yeah,
if not, there is
because
no
of the
drop.
internal resistance. Yes. And V2 plus V3 plus V4. Now I can happily apply what?
Can they give the same question without the internal resistance of the
Yeah,
cells?
without internal resistance. So without internal resistance are really easy. If they have just
So
applied internal resistance to the calculation get bit complicated. I
Okay.
so
R1.
without internal,
So
without
first
it.
finish this and let's do an example. The same thing without the internal resistance of the cells.
In the first one, I add without internal resistance. See, this one I didn't add any internal
But
resistance.
here there are two. But so
Yeah.
still so it's E1 minus E2 is equal to V1 plus V2. That's it.
Yeah. I simple R1 plus I simple R2. That's it. Understand?
Yeah.
Yeah.
This is what the Kirchhoff's
Simple
rule.
for internal. No?
Yeah. Got that point?
So what's Kirchhoff's first law again? That's the easy one, right? The
Yeah.
That's the current one.
Current.
current same voltage.
Yeah. Second one is voltage rule. The first one is current rule. Got that point?
Yeah.
So in my tute, I include many calculations regarding this one.
So without internal resistance, this would just be just scroll up for a second.
E1 minus E2 is equal to V1 plus V2. Because
V2,
there won't
Yeah.
V2 only, V3 and V4 is not there. So you
Yeah.
might get one cell only with internal
With
resistance, other one without internal resistance.
without.
Yeah, you might get those things. Who knows? So mostly internal resistance is marked like in some other way as well. So normally internal resistance sometimes we mark like in this way. Yeah, it's a cell. And the resistance, outside resistance. Meanwhile, the internal resistance is going to mark like this way with simple R. Internal resistance marked as if resistor connected outside to the battery like that. But this one is what? Internal resistance. Get the point?
Yeah.
Yeah.
So that means the cell has its own resistance.
Yes.
Yeah.
Cell has its own resistance.
Why does that happen? Some electrons are used up or like released as heat or something.
What?
Why is there inter resistance? Like there is some energy converted into other like forms. Like electrons are
Because
converted.
all the cells are made out of what? Some chemical compounds.
So the efficiency is in 100% basically.
Not like that, because the chemicals have kind of resistance. In a battery, really simple one, like a volta cell, O level knowledge, or not O level, actually grade 7 knowledge. Can you remember how to make a simple cell?
What, with like a potato or something?
Yeah, potato, chili, or anything. So if you add like some acid, and one is a zinc plate, the other one is,
Yeah, yes, electron.
other one is copper, right?
Chemistry don't.
You connect this one with the voltmeter. So even now the electrons have, the other materials have to pass through from here to here and exchange. So in this manner, it creates some resistance internally.
Yeah.
That's called the internal resistance. Okay, but they don't ask how does the electron, what is it called, internal resistance to create. You don't want to worry. Okay, understood that?
Yeah.
Now the one of the easiest thing, that means the potential divider here, this part. So the potential is divided according to what? The magnitude of the resistance we know as a theory. We just know as a theory, right? But here only you will see it like what? mathematical grouping as well. Now have a good look at, I'm not going to draw anything new. You have some 6-volt power supply. There is a certain resistor. What is it? 10 ohm. The other one is 20 ohm. So this one, the small one only take what? 2 volt, and the bigger one takes 4 volt. That means almost twice, because these two have the same ratio, like 1 to 2 ratio. The voltage also keep in the same ratio. Got the point?
What?
This one.
Voltage resistance.
Have a good look at the ratio of the resistance.
Okay.
It's
Current
10,
is same.
yeah,
So
10
current
to,
is
yeah,
voltage to
yeah,
resistance ratio.
yeah, 10 to
Okay.
20. 10 to 20 means 1 to 2 ratio. And this one is
Yeah.
2 to 4 ratio. That means it's also 1 to 2 ratio.
Yeah.
So how to get this?
Do they get the same current?
Huh?
Doesn't it split?
Same
So
current,
point.
same current, because why? There is no path to
Okay. Yeah, they are in
only one
series.
path. They are in
Yeah.
series. You may see these
Voltmeters, yeah.
but the voltmeter consume no current according to what? An ideal voltmeter theory. Ideal voltmeter means it has an internal extreme, but infinite level of
Low.
resistance. Infinite resistance means it doesn't draw technically any current.
Infinite resistance or low
Yeah, yeah.
resistance?
Infinite resistance for an ideal voltmeter. You can't make any ideal one, because why? When the resistance is infinite, that means there's no current coming into the voltmeter to do the basic functioning. So actually it draws certain volt current, but it's negligible. Okay. So I know that the I current through this one is constant. Like if I consider like I1, this one is I2. We know that I1 should be equals to I2 as well. So what is V according to Ohm's law? I1 equals to V1 over R1. This one is equals to V2 over R2. So we can equal what? I1 to I2. So V1 over R1 equals to V2 over R2. Rearrange the equation to make it like V1 over V2 equals to I2 over R2. So you may just modify this in this way as well. V1 to V2 ratio is equals to R1 to R2 ratio as well. In terms of ratio, sometimes this might help you in way more than the other conventional method. Okay.
Sir, I1 equals I2, you got that because in
Yeah, it's
series
the
it's anyway.
only one path. See the loop.
So
There is only one loop, no junctions. That's it. If there's a
basically
junction,
because it's series.
yeah, that's because of series. Yes. Now this one is the best part you need to know. There are two methods to remember this. I will teach you in both the ways. Okay. So have a look at. There is a what? Power supply. That means an EMF provider, an ammeter. So there is a variable resistor and a resistance wire. Using this resistance wire, you may use the output what? Voltage through this resistance wire. Got the point?
What is the resistance wire?
Resistance wire means anything, or any wire like nichrome. Those have really high resistance.
Okay.
So that wire, according to the length of the wire, resistance vary. You know that the resistance equation called what? R equals to rho L over A.
Yeah.
So what did you say in the beginning, sir? When you were describing the circuit?
Yeah, wait. resistance is directly proportional to length. No, when the length increase, resistance increase. Matisi, what did you ask?
What were you explaining first about this diagram?
Resistance wire.
No, this one, the EMF provider. It provides some EMF, and there is a what variable resistor. The variable resistor keeps like V1 voltage, and it transfer the other voltage like V2 across the resistance wire. So potential divider equation. So according to that one, this is what V in, like the total voltage supplied. I will draw this diagram again. The supply voltage, we call it like what? V in. Now I'm going to get my V out from here. And there are two resistors. One is R1, the other one is R2. You have to know one thing, the current is constant throughout the circuit. I got the point?
Yeah.
Okay. So what can I say about this one? Applying what? Applying Ohm's law to R2. V out equals to I R2. This is equation number 1 what I'm getting. V out equals to I total current and multiplied by the resistance of R2. Okay. So what can I do after that? I have to find out the current.
Yeah, out means you are measuring the voltage there. Like assume there's like a voltmeter there or something.
Yeah, you can use any voltmeter or something.
Okay.
Okay, now
Any
what is according to who?
According to what?
Kirchhoff's second rule, total supply should be equal to V1 plus V2 like that, etc., etc.
Yeah.
Like that.
The
V in is the king here in the supply. What about the other things? I R1 plus I
R2.
R2. So V in equals to I times R1 plus R2. So I need to get I. How to get I? V in over R1 plus R2. That is my equation number 2. At that point.
Yeah.
So what can I do now?
Substitute I in that other equation.
Substitute equation number 2 into equation number 1. So V out equals what? I is what V in over R1 plus R2 times what? R2. Now this looks really weird. I have to just make it easy. V out equals what? R2 over R1 plus R2 times V in. This is what my finalized equation. Understand?
Let V out equals R2.
I send it in WhatsApp. All the notes.
And what you wrote?
Yeah. All the old stuff.
Okay.
So wait, so in the this thing you have written V out equals V in over R1 plus R2.
2 as the current. This part is current.
Yeah.
So I
Yeah,
rearrange that equation in a like some user-friendly way. R2 over R1 plus R2 times V in as a fraction of it.
Okay. Okay, fine.
So if you don't remember the way like how to deal with this equation, there is a one method you can apply. That is what? So you used to do this one in your O level. Yeah, and even A and B spent what? Money on certain project in the ratio of 2 to 3 ratio. O level max. If total profit made like $10,000, how to get the amount getting by A and B. How to get the value of A? A equals what? A's part is 2, 2 plus 3 times 10,000. That's the same method applied there, isn't that? See?
Ah, we did this today. I was wondering what he was explaining in school. Oh my god.
This one?
Yeah, we did this in school. I was wondering what he was explaining also. He just rushing through the lessons now because we can't finish this.
Ah, yeah. See? Isn't that the same thing?
Yeah.
It's as same as what? If you can remember the original derivation and all the stuff, that's fine. If you can, just think about that in the O-level, like grade 7 maths knowledge.
Yeah.
I warn you. So your school will begin to rush like nothing. But you told me, no, sir, we are in a very healthy position now. We are still doing this lesson. I told you when the mocks are just around the corner, they will just rush like nothing. Now it happened.
That means maybe tomorrow he might do potentiometer and these things. Swimming or whatever.
Okay. So now can you understand this whole shit?
Yeah.
That's a really simple thing, and the potentiometer. So in terms of potentiometer, you have to remember one thing. Let me explain you. So we just connect it like this manner. One wire to this one and the supply. Other wire to this one, this end, and supply. Right here. Right? So how about, so the current will just gain by this one and pass through here. Oh, wait. Pass through, and the current is moving along what these type of coils. Like when you touch one line, zero line, that means the potential is zero. One line, 1 times R, 2 times R, like that. You know the R equals rho L over A. L here is what? 2 pi R. That means the circumference.